is Srikanth, working as assistant professor in electrical department. I want to go to Thevenin's theorem, but not DC excitation with AC excitation. So I have some problem here. Using AC excitation, we need to solve Thevenin's values. So VTH as well as RTH. We'll check it now. Just observe the circuit. So one voltage source I have, capacitor, resistor, to resistor and inductor. Generally, what is the Thevenin's theorem? So any bilateral network consists of several voltage sources, several current sources, like number of sources and number of resistors, like passive elements, can convert it to single source and single voltage source series with the single resistance, the impedance. Okay, so any bilateral network, so this is the one network converted to one voltage source, that is a AC, and one impedance, ZTH. Like not a value here, that is VTH. VTH AC, not DC again. So VTH and ZTH. Here impedance. For DC we have like voltage source series with resistor for DC. For AC we have impedance series with one voltage source. Okay, so any circuit converted to one single circuit, so voltage source series with one impedance. So I need to find out VTH and ZTH for Thevenin's. Now if you observe the circuit, so don't bother about the circuit. If you draw clearly, we'll get the answer. Okay, now for this circuit, first I want to find out the ZTH. For ZTH, we need conditions we have. Yes, for Thevenin's theorem, when you are finding the ZTH, we have small conditions. So any voltage source can short circuit. So here is the voltage source. We need to go for the short circuit. If you have the current source, need to open circuit. So in our circuit, we have only one voltage source. So it's short circuit. So then draw your circuit now for ZTH. For ZTH, your circuit voltage source, it's short circuited. Okay, remaining as it is, that is capacitor and AB. This is a, here I think load. Here we have the load RL we have. Okay, in exam it isn't given any load here. So here we have ZTH equivalent value. Here I need to find out the equivalent value and resistor as it is. So resistor as it is, and here I have one more resistor. Here I have inductor. It's short circuited. So this is your general circuit for ZTH. Between A and B, I need to find out the equivalent value. If you observe the circuit, so which is a series, which is a parallel, can you guess? It's somewhat difficult to guess which is a series and which is a parallel. So for that, I want to go to one more circuit, E and C. Now here B and F. So here D and F both are connected to one point. Am I right? So there is no element in between. There is no element. So I want to draw same circuit to another same circuit but different manner. Now D and F, same place. So D and F at same point. Now at D and F same point means we have 1, 2, 3, 4. So total 4 parameters connected. Now at D and F we have D2 one capacitor and F2 one resistor. So both connected to E point. So here D and E and F. So D and F is one point. So F2E, D2E. So D2 one E I have. So D2E is your capacitor. D2E I have capacitor. Same D2E I have resistor. So D to E, I have J6 and saying D to E means F. We have 8. Okay, now completed. Again D to F, D to F I have the 4 as well as 2Z. So D to C and F to C. So D to C has a resistor and one inductor. Okay, and this is the E point and this is the C point. So D2 E I have a capacitor and F2 E I have a resistor. Same D2 C I have a resistor and F2 C I have one inductor J 12 ohms. And this is the 4 ohms. Clear? For Z value, for ZTH, I can draw like this also. Now, if observe, so between E and C, am I right? Between E and C, so that means A and B, I need to find out the equivalent value. Now, both two are, you can see, both two are parallel. Here, both two are parallel. Then series. It's very simple. Then you can find out the ZTH value. If you have the calculus, you can find out the ZTH value. It's very simple to find out. Now both are series means. So here I have D and F. So I have an impedance, and here we get one more impedance. Here A and here B. This is a Z1 and this is a Z2. So Z1 equal to capacitor and resistor. Both are in parallel. So minus J parallel with J6 parallel with 8 ohms. And Z2 equal to 4 parallel with J2. So parallel, when they are parallel, we know the formula R1 into R2 by R1 plus R2. Just substitute those formula. So your Z11 equal to Z1 equal to 8 into J6. So minus we have minus J6 by 8 minus J6. Okay. Then we have Z1 value is, so for this, first convert into polar form. That is a simple one. So here we have, using calculus, it's very simple to find out that polar to rectangular. So 48 minus 48J by converting to polar now. So your Z1 value. So Z1 value is now convert into polar. So polar to rectangle, rectangle to polar, you need to know. So in calculus, it's very simple. So 8 into minus J. So you can convert into polar form. So polar of 48. So not 48, 0 comma minus 48. So we have 48 angle with minus 90. Divided by, here 6 minus J is there. So 8 minus J. So polar 8 comma minus 6. We have 10 angle with minus 36.86. Now your Z1 value. So Z1 value is, you can divide directly. So 48 divided by 10, we know like a 4.8. So 4.8 angle with, so both angle in division position. When both angle is division position, you can subtract those values. So minus 90 and minus of minus, we have the plus 36.86. So what's the value? The value is minus 53.14. Now Z1 value in rectangular form. So Z1 value in rectangular form 4.8 comma minus 53.14. The value is So 2.87 minus 3.84. J 3.84. This is your Z1 value. Coming to Z2 value is, so Z2 value is again 4 into J12 by 4 plus J12. So the value, so plus, y means inductor is not capacitor. Capacitor means we go for the minus. Here inductor, we have the plus value. So now 4 we can convert into polar form. 48, same will get like a, which we have. So 48 with J means 48 angle with 90. Not there we have the minus 90. Here we have the minus 90. Here we have the plus 90. Same 12 into 4 48. Here 6 into 8 48. Now we have one more 4 comma 12. 4 comma 12. The value is 12 angle with 12 point. 12 point. So 12.64 angle with 71.56. Here what is the angle? So now you can divide directly. So 48 divided by 12.64, the value is 3.79 and 90 minus 71.56, the value is plus, not plus, angle with 18.44. Now it convert into rectangular form. So 3.79 angle with 18.44, the value is 3.59 plus 1.198 J. So Z1, Z2. So we know like Z1 value, Z2 value. Then your equivalent ZTH. ZTH is, now both add. Series means you can add both. So 2.87 minus J 3.84 plus, so Z1 value this is, and Z2 value. Z2 value is 3.59 plus J 1.198. Now your ZTH. ZTH is 2.87 plus 3.59. So we'll get like 6.46. Okay, and J we have minus 3.84 plus 1.198. The value is minus J 2.6. This is your ZTH value. So for this circuit, your ZTH value, so ZTH is 6.46 minus J 2.64. This is your ZTH value. So for ZTH we know the value. Now I want to find out the VTH. So for VTH, I want to draw same circuit with my easy manner. Okay, just observe now. Voltage source is as it is. Okay, now I have one capacitor here and one resistor. Okay, same circuit. Just check it now. Here A and here B. That's it. Okay, remaining as it is. Okay, but I want to draw in easy manner. And here I have one inductor, that is a J12, and here 6, so 8 ohms, and minus J6 ohms and 4 ohms. Okay, and here 120 angle with 75 degrees. Okay, this is my circuit now. Same circuit. I want to draw like this. Now I want to find out the VTH value. So I want to find out the VTH across AB. But before moving to VTH I want to solve in simple manner. Okay, so suppose here I1, here I2. So these are parallel. So this total, so here to here and here to here, the circuit is parallel. So don't worry about like AB value. So VTH value. So I1 branch and I2 branch, both are parallelly connected to our voltage source. Now voltage drop here and voltage drop here same. So in general, V equal to I into your impedance. Now I want I value, so V by Z. So for I1, what is your impedance value? So what is the voltage value? Voltage value as it is, that is 120 angle with 75. And what is the impedance value? So both in this branch, capacitor and resistor, both are connected in series. Series means the value is 8, capacitor is minus. Okay, right? Capacitor has minus J6. Coming to I2. I2 we have same voltage. So parallel voltage is same, 75 degrees, and both are in series. So 4 plus J12. Now convert into polar. So for polar, so denominator will be changed. So denominator for polar 8 comma minus 6. So we have like 10 angle with minus 36.86. Okay, now coming to here, I2 same polar 4 comma 12. So value is 120 angle with 75 as it is, and here value is 12.64 angle with 71.56. Now your I1 I2 values. Coming to I1 I2 values, I1 value is, so 120 divided by 10, so like 12. Okay, angle with 75, minus into minus we have the plus. So when angle is division position, we need to subtract those values. So here we have the minus 36, so minus into minus plus, so plus 36.86. the value is 311. Yeah, 311.86. and coming to I2 value, so I2 value is 120 divided by 12.46, so 64. The value is 9.49 angle with 75 minus 71.56. The value is 3.44. So I have I1 and I2. Why I need to find out the I1 I2 means, if suppose your circuit, this is your circuit, now it's in closed path. Okay, now it's closed path, then what is the value in this closed path? Apply the Kirchhoff's voltage law. In a closed path, voltage is equal to 0. So apply the Kirchhoff's voltage, I will get the VTH value. So VTH value is VTH equal to, so look, closed loop. Closed loop means, so we have like a VA. So this is a VA and this is a VB. So VA side, VB side, VA plus VB. Am I right? No, here check the direction. A direction downwards and this direction are downwards. So if suppose you want to follow this direction, so this is the reverse. So we have a minus otherwise. Minus VA plus VB. Clear? So both current direction are reverse. If you follow the I2 direction, so I2 direction are following. So this is plus, this is a negative to positive, and here positive to negative. It's a reverse. So we have VA minus VA. So VA minus VA plus VB. That is a very VTH value. In a closed loop, the voltage is 0. So VTH, we are following VTH, and VA is minus, VB is plus. Now VA value is depending upon your capacitor. So minus J6 into IA, so I1 plus 4 into VB, that is I2. Okay, this is VA value, this is a VB value. Now, so here we have like a minus and minus plus J6 into your 12 angle with 11.86. Okay, plus 4 into 9.49 angle with 3.44. So just convert into polar form and so rectangular form and find out the value. So here 12 into 12, here we have the value is, so 72 angle with 72 angle with, so both angles, so J, we have J means 90, so 111.86 plus 90, so we have 201.86. and coming to like side VB side, so 4 into 9.49, the value is 37.96 angle with 3.44, so the angle is same. Now here 4 angle is 0, so real values angle is 0. Now the value is, so both are in plus position, so it convert into rectangular form. 72 comma 201.86, the value is minus 66.82 minus J 26.8, okay, 80 plus 37 also need to convert into rectangular form. 37 comma 90, so 37.96 comma 3.44, the value is 37.89 plus J 2.27. Now your VTH value is minus 66.82 plus 37.89, the value is minus 28.93, and the imaginary values minus 26.80 plus 2.27, the value is minus J 24.53. so in your polar form VTH, so you can write like VTH equal to minus 28.93 comma minus 28.93 comma minus 2.54, 24.54, the value is 37.93 angle with minus 139.69. so this is about Thevenin's value. So any circuit, don't bother about circuit, just find out step by step and get the answer. So generally DC circuit is very simple, but comparing AC circuit, we need to know the rectangular polar formation as well as which method easy for us. So any circuit, just go for the simple circuits and find out the ZTH value and VTH value. So for this circuit, we have a ZTH means these two in parallel and these two in parallel series with one value. So that is your ZTH value. And coming to our VTH, so I want to find out like current values when the voltage is parallel to the branches. So I1, I2 values, and use the KVL rule, find out the VTH value. So VTH value, so VA minus VA plus VB, then we have the VTH value. So for that we need to know the rectangular polar to rectangle. It's very, very important. So use a calc is better and find out the polar to rectangular polar values. Okay. So this is about the Thevenin's theorem for AC excitation. Okay. In next video I will go for the Norton's theorem for AC excitation. Keep watching my videos. Any queries, contact me in comment box. Thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.